Okay, so looking at these two. For the first one, remember there's three possible relationships. We either have two things that add up to make a total, they subtract to make a difference, or they are equal. For the first one over here, what situation do we have? They have to be equal because they're vertical angles. So 3x plus 12 has to equal 5x minus 2. So to solve that, first thing we have to do, we notice there's an x on each side of the equation. We have to get rid of one of them. So we get rid of the 3x because it's the smaller one. Leaves us with 12 on this side. Over here we subtract 3x. 5x minus 3x is 2x. And we have the minus 2. Next step in solving that equation would be to add 2. So 14 equals 2x. And then divide by 2. So 7 equals x. Are we done there? No. We have to go back and figure out what each angle is. So I have to put the 7 in for x. So 3x plus 12 becomes 3 times 7 plus 12. 3 times 7 is 21. Plus 12 is 33 degrees. Let's do this one just to double check it. So 5x becomes 5 times 7 minus 2. 5 times 7 is 35. Minus 2 is 33 degrees. So we get the same angle. On the other side over here, what's the relationship between those two angles? They add up to a straight line, or 180 degrees, which means they're supplementary. So they add up to 180. 5x plus 27 plus 2x plus 3 equals 180. So now we can combine. 5x and 2x make 7x. 27 and 3 make 30. Then what? Yeah. Equals 180, then we subtract 30. So 7x equals 150. And then we divide by 7. You get x equals 21.4285714.3 approximately. So then what? That's 21 3/7, by the way. So we'll plug it in up here. 5 times 21 3/7 plus 27. Well, 5 times 21 3/7 is 107 1/7 plus 27 is 134 1/7 degrees. 2x, so it becomes 2 times 21 3/7 plus 3. 2 times 21 3/7 is 42 6/7, I should say. Plus 3 is 45 6/7 degrees. Those two do add up to 180 if you add them up. Not the most pleasant of problems because of the fractions. It works. So what if I give you this situation here where we have $7x plus 7 and 2x plus 11 for those two angles. See if you can find each of those angles for me quick. So what's the relationship between these two? Are they equal? Yeah, they're not in this case, no. This one would be equal with this one. These two have to be supplements. They have to add up to 180. So 7x plus 7 plus 2x plus 11 equals 180. So combining 7x and 2x make 9x. 7 plus 11 is 18. So 9x plus 18 equals 180. And now it's just a matter of solving from there. Subtracting 18. 9x equals 162. Dividing by 9. X equals 18. So then up here, 7 times 18 plus 7. Well, 7 times 18 is 126, plus 7 is 133. Then over here, 2 times 18 plus 11. 2 times 18 is 36, plus 11 is 47. So 133 degrees and 47 degrees. One of the next things we looked at was the square roots. I want to make sure you remember how to do the square root like that. The square root of fraction, remember you can split it up. Do the square root of the numerator over the square root of the denominator. What's the square root of 25? 5. What's the square root of 81? 9. So it is 5/9. So in your book, I want you to do the square root of 9 over 49. So what you come out with? It's okay. So, again, you can split that up and you can do the square root of 9, which is 3, and the square root of 49, which is 7. So 3/7. If you tried to punch that in your calculator, it may have spit out something like 0.42857,143. Okay. One of the big things we used those roots for was we explored things like a right triangle. If I know two sides of a right triangle, let's say this here is 9 inches and this is 40 inches, I can find the second side of the right triangle. Or the second side, the third side. The two sides that I have here are the legs. They're the legs because they make the right angle. So those are going to get labeled A and B, and it doesn't matter which is which. The third side, which is the longest side, is always across from or opposite the right angle. That's called the hypotenuse. That's side C. Remember that relationship is A squared plus B squared equals C squared. So now we put those numbers in. A is going to be 9, so that's 9 squared, plus B is 40, so that's 40 squared, equals, my missing side, I'm just going to leave that as C. So C squared. 9 squared is 81. 40 squared is 1600, equals C squared. 81 and 1600 is 1681. Equals C squared. And then we have to square root to get rid of the squared on C. Gives us 41 equals C. So C is 41, and since all the others are in inches, that is in inches as well. Which leads us to an extra credit question I left you guys with last Tuesday. Did anybody get an answer to that one? Last Tuesday? I don't remember if you were or not.
No.
That's right. You were hunting bear. From your camp, remember, you walked due south. Anybody have the distances written down?
6 miles.
6 miles due south. Then you turned and walked due west. How far?
9 miles.
9 miles. At which point you shot a bear. And then you had to walk back. We're just going to make our bear a big brown blob. I won't draw him out. He's dead, so he's laying in a... I should probably make him a big blue blob because I don't want to give you any preconceived notions about the color. So yeah, you had to walk back to camp, and you realized at that point it was still 6 miles to camp, the same distance you were when you turned to the west. The question was, what color is the bear? The answer is the bear is white. How do I know the bear is white? Well, because the only place on Earth that you can start out and walk 6 miles due south and then turn and walk 9 miles due west and still be 6 miles away from where you started is if your camp was at the North Pole. It's called spherical geometry. Since the Earth is technically a sphere instead of flat, the a squared plus b squared equals c squared does not hold true because it's not on a flat piece of paper. On a flat piece of paper, this is a right angle, so this would have to be 6 squared plus 9 squared, and then add them together and square root. Since it's on a globe, it's on a sphere, that doesn't hold true. Since you guys are here, I'll give you another one. Since we talked about square roots and perfect squares. We're going to put this in the middle of the first hour recording to see who actually watches to see this one. Bob and Steve are brothers. And they inherit a ranch from their uncle. Their ranch has 2 cabins on it. And there's a river running through the middle of the ranch. There's a cabin on each side of the river. And on the ranch, they have inherited several cattle. Well, after trying it for a few weeks, Bob and Steve realized they're just not cut out to be cattle ranchers. So they take all their cattle into town and they sell them. The price they get per animal, per cow, is equal to the number of cows they had. What does that mean? Well, that means, for example, if they had 20 cows, they would have got $20 each, which would be a total of $400. Or if they had 30 cows, they would have got $30 each, which would have been a total of $900 that they would have got. But I'm not going to tell you how many cows they had. So they sold all their cows, and the price they got per cow was equal to the number of cows. They're sitting there thinking, what are they going to do with this ranch? They got all this grass, they don't want to have to mow it. So they decide they're going to buy sheep. So they take all of their money from cows, And they buy as many sheep as possible. The sheep are $10 each. So they buy all the sheep they can. So they have less than $10 left. With what they have left over, they have exactly the right amount to buy a goat. And Bob's always wanted a goat, so he used that leftover money, less than $10, to buy a goat. So they've spent every penny of the money they got from selling their cows. They're on their way home. Well, on the way home, they have an argument. They have a fight. And they decide they're going to go their separate ways. Bob is going to stay on his side of the river. Steve's going to stay on his side of the river, and they're just going to divide everything up and not be partners anymore. Problem is, they go to divide up the sheep. There's an odd number of sheep. So when they go to divide them up, of course, there's an extra one. They can't just cut it in half. So Bob bought this goat that he really likes. So what he does is, Bob's going to take the goat. Steve is going to get the extra sheep. To make it even, since we know the goat is worth less than the sheep, when they inherited the ranch, it came with a cattle dog, a herding dog. So Bob's going to get to keep the dog. So the question is, what is the value that they just put on the dog? So you have to find the value and explain to me why the dog is worth that, why that much value is put on the dog. Obviously, it's the difference between the cost of a goat and the cost of a sheep, and then $10 for a sheep. Not as tough as it looks. Any questions on that one? Okay. Anybody think they're even going to try that one? Negative? They'll try it? I will give you one hint. It's a big hint. Make lists and look for patterns. Look for a pattern. It's one of those, once you see the pattern, the answer is really, really simple. Okay, so enough of that. Let's now take a look at that one. By the way, the first person to give me the correct answer, if you want to email it to me to make sure you're first, I will give them up to 20 points for it. Everybody after the first person, I'll give 10 points for giving me the correct answer. I will let them tell you. If you're first, I will tell you who you are, and I'll let them tell you if they want to. Okay, so I want to review a little bit of this Pythagorean theorem with the right triangles quick. So let's say that we're looking at a sidewalk. Where this is the student dorms. And over here is the entrance to the cafeteria. And the problem that they're having is students tend to just walk right across the lawn from the dorms to the cafeteria. And the lawn is taking a beating. So they are going to install a sidewalk across here. so they can just walk across. The distance from the dorm out to the main sidewalk is 120 feet. The distance from that sidewalk to the corner of the cafeteria is 350 feet. Find for me the length that sidewalk's going to have to be. So in these problems, the first thing you have to do is figure out where the right angle is. In this one, where's the right angle going to be? Right here, right between the 120 and the 350. So I'm going to give you guys a second in your notes. Find the length of that sidewalk. So, which sides are the legs? The 120 and the 350 are the legs that make the right angle. So I'm going to call those sides A and B. So what I'm looking for is side C here. So A squared plus B squared equals C squared. I'll put in 120 for A, so that's 120 squared, plus B is 350, so that's 350 squared, equals C squared. $120 squared is 14,400. 350 squared is 122,500, I believe. Equals C squared. I add those together, I'm going to get 136,900. C squared. If I square root that, I should get what, 370? We'll see. So that is 370 feet across there. So they want to measure the height of a flagpole. They managed to attach a rope to the top of the flagpole. What they do is they take one of the hooks for the flag and they run it all the way up to the top. And this rope is, what do I put in there? Let's say that it is 25 feet long. And when they stretch it out, it goes 7 feet away from the base of the flagpole. So in your notes, figure out for me how tall is the flagpole. So in this one, the height of the flagpole is one of my legs. So I'll call that A. The other leg is the 7, B, because my right angle is right there. Hopefully the flagpole is perpendicular to the ground. So then my rope length of 25 is C. So A squared plus B squared equals C squared. Where A is what I'm looking for. B is 7, so that'll be 7 squared. C is 25, so it's 25 squared. 7 squared is 49. 25 squared is 625. And we will subtract 49. So A squared equals 576. And then square root. A equals 24. So that's 24 feet. What do you think? Easy? Good deal. We talked briefly earlier about area. So I want to go back through one more time and defining how area come from. We talked about angles. We talked about all geometry starting from a point. and that point being pulled in a single direction to create a length. And that length, of course, is equal to the distance we moved the point. We moved it in one direction, that is now one dimension. A dimension is a measurable characteristic or a measurable direction on the object. Now, if we take that length and we move it in a second direction, if that second direction is what we remember we talked about perpendicular, it's moving at a right angle to the original direction. The biggest thing is that we stay at the same orientation. So it stays parallel to the original direction. We pull it perpendicular like that. Think of dragging a stick across the sand. It traces out a rectangle. We have now gone in two directions. It is two-dimensional. The size of this rectangle, or the area of this rectangle, depends on what this original length was and the distance that we moved it. That distance is often referred to as a width or a height. If you're thinking of it as being flat on the table, it would be a width. If you're thinking of it as standing up on a wall, it would be a height. So the area is equal to that length times that distance, or that width, we'll call it for now. So if I give you a rectangle, technically I should give you at least one right angle in the corner to tell you that that's a rectangle. If this is 12 inches, and this is 5 inches, its area is that length of 12 inches times that width of 5 inches. Now when we multiply the counts. 12 times 5 is 60, but we also multiply the names. Inches times inches is inches squared, or square inches. Now that squared there on the inches does not affect the number, does not affect the 60. All it is doing is telling us that that's not regular inches, that it's square inches, it's a unit of area. In fact, one of the definitions of an area is a bunch of thin rectangles stacked up together, like that. If you think of it like that, we can actually do variations of this. For example, let's say I still start out with my 12-inch length. But this time, instead of pulling it perpendicular, I'm going to pull it at an angle. But I am still going to keep it parallel to its original orientation. Notice here it's still parallel to the way it started, but I'm pulling it off to an angle like this. Now, this dimension here does not matter. What matters, just like we said, is the distance from where it started to where we stopped. That distance is from here to here. Distance is always measured at a perpendicular. Well, if that distance is still 5 feet, or 5 inches, I should say, the area of this is still just 12 inches by 5 inches, or 60 inches squared. So I've got this, it's called a parallelogram. It has a length of 20 feet. Would I do 20 times 15 to find its area? Say no.
No.
Why do I have to use that 13 feet? Because it's perpendicular. For areas, I always have to multiply two perpendicular dimensions. And that 13 feet is the actual distance from where it started to where it stopped. So the area of that, 20 feet times 13 feet. 20 times 13 is 260. Feet times feet is feet squared, or square feet. So when I'm finding areas, it's the distance from where it started to where it stopped that matters. And that always has to be two dimensions that are perpendicular. So back to that original 12-inch piece again. We had said we don't have to pull it perpendicular as long as we keep it parallel to its original orientation. In fact, we don't even have to pull it straight. As long as it stays parallel. Notice it's still parallel. We move that way, we can move back this way. Still parallel. And maybe back this way again. So we got something like this. As long as the distance from where we started to where we stopped is still 5 inches, what do you think my area is? Still 12 inches times 5 inches, or 60 inches squared. It's because, remember, we talked about that area being a bunch of really thinly sliced rectangles. I think of this here. Even though it's at a slant here, the number of those rectangles it's going to take to stack all the way up is going to be the same as here, because it's still 5 feet all the way up. The same down here. The number of those rectangles it's going to take, it's still 5 feet all the way up. It's still going to take the same number of those little thin rectangles to stack up to that height, to get that area, even though they're not stacked straight on top of each other. Does that make sense? Not really? Kind of? Okay. Pretend that's a parallelogram. So with what we've seen tonight, could we find the area of this? Do we need the 20 times 13? Is that what we're going to do? No. It'd be 20 times whatever this height is, right? That's perpendicular. Do we know that height? Not directly, but do we know how to find it? Yes, if I call that A and this is B, those are two legs of a right triangle. 13 is the hypotenuse, that's C. So A squared plus B squared equals C squared. A is what we're looking for. B is 5 feet, so 5 squared. Equals C is 13, so 13 squared. So A squared plus 5 squared is 25 equals 13 squared is 169. Subtract 25. A squared equals 169 minus 25 is 144. And then square root. A equals 12. Any questions? Well, how about this? A right triangle, if I want to find its area. Well, the only thing we know how to find the area of so far is a rectangle. And that works perfectly for this. We can finish off that rectangle that rectangle would be 12 by 5. So that area of that rectangle will be 12 inches times 5 inches. How does that triangle relate to the rectangle, though? It is half, divided by 2. Perfect. So 12 times 5 divided by 2 is going to give us 30 inches squared. 12 inches times 5 inches is 60 square inches. Divided by 2 is 30 square inches. So the area of a triangle is always half of the related rectangle. Now here the triangle is a right triangle, but it doesn't have to be. This one looks like it's close to a right triangle, but it's not. I'll tell you that. And let's say that this is 30 feet here. What we need to know off of this now is not any of the other sides, but we need to know what would be the width of that related rectangle. The 30 is going to be the length. The width, however, this distance here. And to find that on the triangle, it would be the distance from my width or my base of 30 feet to the furthest point on the triangle. In other words, the opposite vertex. That's referred to as an altitude or a height, the height of the triangle. And let's say that that is 8 feet. Well, this triangle is still half of that related rectangle. So its area is 30 feet times 8 feet divided by 2, which is going to give us 120 feet squared. How about you try one? So let's say that this is 17 inches. That's 20 inches. Find the area. The area is going to be, what two numbers do I multiply? 17 inches by 20 inches. And then divide by 2. 170 inches squared. A little bit harder to understand is a triangle that looks like this. Let's say that this down here is 14 feet. The altitude of this, the height of this, is found off over here. This is still the height of this triangle. And let's say that that is 7 feet. Now it's 9 feet, that's more proportional. The area of this triangle is still just the 14 feet times the 9 feet divided by 2, or 63 square feet. Now looking at that, you're wondering, how is that really half of that related rectangle? Well, it's kind of hard to show, so don't necessarily write this down because it might be a little confusing. If I look at this big rectangle, if I think of the area of this rectangle here, which is created by that base of 14 feet, it would be the big green rectangle minus this little red one, right? Does that make sense? Well, the area of the triangle is half of the big green rectangle minus half of the little red rectangle, which is half of the purple rectangle. I know, it's kind of confusing. Anyway, just trust it's still half base times height divided by 2. Okay, it's break time. Let's go ahead and take our break. We'll come back at 4:30 and start talking about more new stuff.